its encoders are very common electronic circuits which we use in all digital systems. So encoders are used to translate the decimal values to binary in order to perform binary functions such as addition, subtraction. So there are like four main encoders. So one is priority encoders, second one is decimal to binary coded decimal, and then third one is octal to binary, fourth one is hexa to binary. It means hexadecimal to binary encoders. So priority encoders means they will be it will be given a priority for the highest value. Then the decimal to binary BCD converter is a general one. Then octal value to binary, octal values can be translated or else encoded into binary bit forms. So then hexadecimal values also can be converted into binary. So here is the structure of a encoder. So there will be n inputs, 2 to the power n inputs. Regarding the n inputs, the outputs will be decided, right? So I will be explaining this scenario in the later part. So you can see here, if the number of inputs m are 2 to the power n is equal m, we can have n number of outputs. It means, assume, I will explain this through an example. If we have 4 inputs, right? 4 inputs, 1, 2, 3, 4. If we have 4 inputs to this encoder, okay, 4 can be written as 2 to the power 2. So 2 to the power 2 is 4. Now here n is act as 2. So this n is the number of outputs. So if we have 4 inputs from this side, we will have 2 outputs from this side, right? For that kind of a scenario, we called as 4 by 2 encoder, because we have 4 inputs and 2 outputs. Here you can see the truth table and the logic gates. So what we expect from this one is, so if we want to represent, if we have 4 variables like 1, 2, 3, 4, this whole bit stream, this whole data stream can be represented only using 2 set of outputs using A0 and A1. So if we input 0, 0, 0, 1 to this encoder, it will get encoded as 0, 0. Okay. So if we input this column, sorry, this row up to here, this 0, 1, 0, 0, it will get encoded and you will get output as 0, 1. So then if we get 0, 1 as the output, then we should be able to actually assume that this should be the encoded value. If we get 1, 0 as the output, we should be able to assume that this should be the input value, 0, 1, 0, 0, right? So that so here you can see A1 column and A0 column. So what if I add y3 and y2 values? Now y3 and y2. Just pay attention to this A1 column. If I add y2 and y3, 0 plus 0, it's 0, right? Again 0 plus 0, here it's 0. 0 plus 1, it's 1. 1 plus 0, it's 1. So we can derive an expression. This A1 column is equal to y3 column plus y2 column. This A1 column is equal to y2 column plus y3 column. Similarly, this A0, right? Consider this y3 and y1 column. y3, y1. y3, 0 plus 0, it's 0. Okay, this 0 plus 1, it's 1. This 0 plus 0, answer is 0. 1 plus 0, answer is 1. So this A0 column can be represented as y3 plus y3 column plus y1 column. So regarding this truth table, I have generated these equations. So I can draw truth table according to this. I can draw the logic gate according to these two equations, right? So you can see here y2 plus y3, y2 plus y3, y2 and y3 will come, it will give output, that is a1. y3 plus y1, y3 is coming like this, y1 is coming like this, those two will be added, you will get a0. So this scenario I'm gonna practice from Logism software. So let me move on to the Logism software first. So you can see here the same table, same 4x2 encoder, right? So what I'm going to do is, here you have the truth table, right? Here we have the truth table. I have drawn this one for easier. So I will be getting some gates. What I need is, I need O gates. So by clicking this drop down menu, I take this O gate, I will place it here, and I will be reducing the number of inputs to 2. Here you have 5, I will reduce that one to 2, right? I will take another O gate and I will keep it here. I will reduce the number of inputs to 2. Okay, now I have input 2 O gates. So let me name this one. I will name this O gate as 2. My second O gate is as 1. Okay, now I'm going to connect. So I have outputs like this. I have inputs from this, and from this, and from this. You can see here y3 is common for both gates. So this is y1, this is y2, this is y3. So I will be taking another line from here, a wire from here, as the input of this gate. Right, I'm going to input 3 switches actually, pins. One pin here, another pin here, and another pin here. So now I'm gonna fasten these two ends. And I'm gonna label this one as y1, this one as y2, this one as y3. So I'm gonna make an output here. Again, I'm gonna add another pin, display pin here, and another pin here, so that you can easily identify the outputs. Now I have completed my circuit, and I need to name my outputs. This output I will name as A0. This output I will name as A1. Okay, now I have completed my circuit. So I want to show the simulation process. I'm checking the simulation is enabled or not. No, it's okay, it's enabled. Now I'm going to choose this hand tool. So what I want to show is, I'm going to encode. Actually what I'm going to do is, assume that there is a box like this. So So that's the encoder. From that box we will be inputting. When we will input those three values, it will encoded and it will be reduced to two outputs. The data bit is reduced actually to two outputs. So that's the thing now we are going to do. So when the inputs, when y1, y2, y3, y1, y2, y3 are 0, 0, 0, a1 and a0 are 0. You can see it's satisfied. Now y1 is 1, other two are 0. y1 is 1, I'm going to enable this one. y1 is 1, other two are 0. Then the result will be 0, 1. Here a1 0, a0 1. We will get 0, 1 as the output. You can see 0, 1. Okay, now I have fed these three weight data set 0, 0, 1. Instead of 0, 0, 1, this from this encoder it is transmitted 0, 1 as the output. Sorry, 1 0 as the output. Okay, so then after I would like to go for the third column, y1, y2, y3, 0, 1, 0. Here I would make as 0, 1, 0, 0, 1, 0. When 0, 1, 0 is there, we get 0, 1 as the output. We can say 0, 1. That condition also satisfied from this encoder. And then I will be moving to this 0, 0, 1. 0. I will make this one as 0. Again here 1. Then both are in active high stage. You can see it's active high stage. So this is the simulation of 4x2 encoder. So the initially this y1 y01 is it's negligible. Actually it's there, we are not connecting that one. Only these three will get connected to this OR gates. So this is 4x2 encoder. So let me move on to my tutorial again. So you have seen this 4x2 encoder. Now I'm going to shift 8x3 encoder. 8x3 encoder means you have 8 inputs, right? So this 8 input can be reduced to 3. How it is possible? So 2 to the power, how much is 8? 2 to the power 3 is 8, right? So 8 is 2 to the power 3. So it means if we have 8 outputs or 8 inputs, if we have 8 inputs, we can reduce that to 3 outputs. So that's what 8 to 3 encoder does. So you can see here the truth table regarding 8 to 3 encoder and the relevant simplified expression for A1, A0, A2 as the above example. So if you check, y7 is common for all. Y7 is common for this column is common for this A0, A1, A2, these 3 columns. Y7 is common. So let me check just one value. A2 can be formed. A2 value can be formed. Y7, Y6, Y5, Y4. 4, 5, 6, 7. If you add 4, 5, 6, 7. If you add this 0, this 0, this 0, this 0. Answer will be 0. I will take this one, this value. Okay. If I add this value, 0 plus 0 plus 0 plus 1. What is the answer? It should be 1. So here we have 1. Similarly, like this, we can generate 8 to 3 encoder. So let me move on to the 8 to 3 encoder using simulation. Here you have the truth table which you have seen in 8 to 3 encoder in my Word document. So I'm going to construct 8 to 3 encoder here using OR gates. So initially what I need to do is I need to create, this is some kind of a complex scenario to build up. So initially what I do is I'm gonna make some wirings. So I will need 7 wirings downwards, one wiring from here to here, and another wiring from here to here, and another wiring from here to here, and another wiring from here to here. Altogether now I have 4, another wiring, 5, another wiring, 6, and another wiring as 7. Okay, and also I'm going to name these inputs now. These are input wires. I will be taking the inputs by randomly connecting from these points. So let me name these points as here y1, here y2, here y3, here y4, here y5, here y6, here y7. Okay, so I have named the main wires. So I need 3 OR gates because I have 7 inputs now, 1 2 3 4 5 6 7. With that I have 3 outputs, so 3 output will be taken from OR gates. I will be selecting OR gate from here. I will put it here, another OR gate, I will put it from here, another OR gate, I will put it from here, and I will be reducing the number of inputs to 2, and I will name this one as A0, and this one I will be reducing the number of inputs to 2, and I will name this one as A1. This one also, number of inputs I will be reducing as 2, I will name this one as A2. Number of inputs should be 2. Now, okay. Now I have to connect these inputs as per the requirements like this. Right? A0 should be connected with Y7, Y5, Y3, Y1. A0. This one should be connected with sorry, actually I have to arrange the it's not 2, the inputs should be 4. Sorry again, the input number is, it should be 4, right? This should be 4. Number of inputs should be 4 because there are 4 variables here. Right? So for this A0 we need to connect y7. Let me join y7. For this A0 we need to connect y5. Okay. Then y3 and y1. Y3 can be connected from here. Y3, and then I need to connect y1. Now I have completed A01. A0th O gate is okay. This one is connected. Now I'm going to connect A1 here. Y7 should be connected. Y6 should be connected. Y7 should be connected. Okay. Y6 should be connected. Okay. Y5 and Y4. Y5 is here. And Y4 should be connected from here. This is my Y5 and Y4. Now A1 is also correct actually. Then I have to move to A2. A2 is this one, Y7, Y6. Y7, I will be connecting Y7. Then Y6, I need Y6. Okay, Y7, Y6. And Y5, Y4. Y5, Y4. Sorry, I have done a mistake in A1. For the A1, it should be Y7, Y6. For A1, it's Y7. Y6. Okay. Y3, Y2. This should be Y3. And there is no any Y5 for this one. It should be Y2 like this. Okay, let me recheck this one again. So for A0 we have 7 5 3 1. A0 we have 7, okay, 5, okay, 3, okay, 1, okay. A1 we have 7 6 3 2. 7 6 3 2. So we have 7, we have 6, we have 3, also we have 2, it's also correct. Then for A2, 7 6 5 4. 7, okay, 6, okay, 5, okay, 4, okay. Now my logic gate is almost completed. So I have to add some pins here in order to display the results. So okay, I will be joining this one and this one also and this one also. So now you can see the output from this one. Also I should need to connect some inputs here. In order to simulate this one, I need some inputs, I need to connect some input buttons here, input pins here. So I'll be connecting some inputs, and this should be heading towards south. Okay, and I connect it here. Okay, now it's connected. Similarly, I'm going to copy paste this one, and another one, and another one, another one. So like this, I can copy and paste rather than clicking and dragging. This method is easy if you have several inputs. So now my circuit is almost completed. So now I can simulate and show you the results. So here you can see there are 7 inputs, and for that we have only 3 outputs. So let me show you inputs. Let me control the inputs. Now here you can see A0, A1, A2 are the outputs. A0, A1, A2. Here, these things are the output. I can label this one as A0. I can label this one as A1. I can label this one as A2. Okay, so you can see here these 3 are the outputs. So these values are the inputs. So initially y0, this column, actually this row y0 is 1 active high, other all are 0. Y0 is 1, y0, sorry, actually you have to come from here, y1 column. This column is negligible, you can add it later if you want. We will be considering and we will be paying attention for this one, y1 0, everything is 0. Starting from y1, everything is 0. Then the output will be 3 zeros. It's okay, satisfied. When inputs are, when 1 and rest of the things are zeros, 1 and rest of the things are zeros, y1 is 1, y1 is 1. I'm going to start simulation. Y1 is 1, right? Rest of the things are 0. You can see y2, y3, y4, y5, y6, y7 are 0. Only y1 is positive, other are 0. Then the output will be 0, 0, 1. You can see 0, 0, 1. Right? 0, 0, 1. If this y1 represent 2 to the power 1, right? So 0, 0, 1 means if you convert 0, 0, 1 into a decimal, this binary number decimal, you will get 2, right? So let me move on to the this one, this row. So we have 0, 1, 0, 0, all the others are 0. Only y2 is positive. So only y2 is positive, other ones are 0. Other inputs are 0. So when the inputs are 0, 1, 0, 0, 0, 0, 0, output is 0, 1, 0. So many input have been reduced. So you can see the output 0, 1, 0. It's also satisfied. Similarly, y3 is positive, other ones are 0. y3 is positive, other everything is 0. When y3 is positive, you have 0, 1, 1, 0, 1, 1, 0, 1, 1 now as the output. Then y3 positive, then we will shift to the other one, y4 positive. When y4 is positive, other things will be 0. Whatever is 1, 0, 0. You can see outputs 1, 0, 0, 1, 0, 0. Then let's switch off this one. Then let's move to this. We will get 101, 101. Then I'll switch off this one. I'll switch to y6. If I switch on y6, this column, others are 0, output will be 110, 110, satisfied. Right? If I switch off this one and switch on this y7 value, what will happen is everything will be light. 1, 2, 3. This is 1, this is 1, this is 1. A1, A0, A2, everything will be 1. So this is the simulation of 8x3 encoders using Logism software. So I have explained you the encoders using 2x4 and 8x3. So I hope you understood everything. Let's meet on another tutorial. Thank you everyone.